Hello guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for more civil engineering updates. Today our lecture is about the crank bars. What are the crank bar and how they are used and why they are used. So let's come to the definition of crank bars. Crank bar are those bars which can resist both the positive moment as well as the negative moments. The positive moments as well as the negative moments. So how? Let's take an example here. Let's take an example here of this beam, and these are the two columns here. Let's take this upper story, first story, and maybe there are some other beams here, and it's going left side as well as on the right side. So what, when the load acts on this column, on these beams, it will transfer the loads to the column, right, to these columns. So the beam will bend like this way. There's a maximum bending moment at the midpoint due to the uniformly distributed load, and here it will bend in upward direction. If I remove the loading, so how it will look? It will bend like this. It will bend like this. Due to load, there is positive moment here acting at the center of the beam, and there at the supports there is negative moment. Due to the load condition, it will bend like in this way, because due to supports here we create the negative moments. Here we have positive moment at the mid, here we have negative moments at both the ends. So what these crank bars are? These crank bars are used to resist both these positive moment as well as the negative moment. Like how? Like if this is consider this is the same example. This is the beam and columns. These are the columns, and this is the beam. So due to this bending moment, positive bending moment at the center of the beam, we will provide the reinforcement here at the bottom to resist the tensile stresses. Here at the bottom, right? Positive bending moments, we will provide the reinforcement at the bottom of the section. If this is the section at the bottom, so we will provide the reinforcement at the bottom of the section. If this is at the support, we have the negative moment, so we will provide the reinforcement at the top of the section to resist the negative moments. Similar case is that one. So let's come in here how we place the reinforcement and how the crank bar is used. Now to resist this positive moment, we place the negative moment here in this way, right? But somehow we place the reinforcement to provide the negative reinforcement to resist the negative moment. We provide the negative reinforcement in this way. But what we do, we actually want to get rid of this negative reinforcement to provide it separable. We want to not to provide these reinforcement at the negative moments. So what we do, we place the crank bars here. So these are the bars, but actually these are bend bars, and they are here. Similarly, these are also bends here in this direction, and now they're here. So the negative moment here creating is the negative moments create here in this direction, in this portion, and as the negative moments creates here in this portion at the supports, now these crank bars are now able to resist the negative moments at the supports, while it can resist the positive moment at the midpoint, which is the center. To the midpoint is the L by 3, for example, L by 3 and L by 3, and here L by 4, L by 4, if this is the length L of the beam. So these crank bars are now able to support the positive moment, and we bend these bars up to the negative section. Why? Because there is no use to place the reinforcement here in this way, in this positive direction, because there is no positive moment acting, but somehow we place the minimum reinforcement throughout the joint. But we don't allow all of the bars to move inside the joint. We bend the bars and move upward into the column, and it bends like this way. So this we call the development length, which is produced inside the column. This is called the development length, and I will upload the video about the development length, how to find the development length in the coming lectures, right? Today's lecture was about the crank bars. So crank bars are used to resist the negative as well as the positive moments. Now, how to find the length of this crank bar? How much it bends? How much is it bends? This is the length of the crank bar. So let's come to the how do we find the length? The length of this negative crank bar can be found out by formula that is 0.42 into D. So I will again draw the picture, the diagram of the crank bar. Here we have positive reinforcement to resist, and it is cranked here, the negative coming here. Similarly, in this way, it is bent here and this way. So how to find this length of the crank bar? This is the length of the crank bar. How to find this length? 0.4 into 2 into D. What is D? D is the distance from this crank, the whole length throughout this. This is the D. Removing the clear cover here and removing the clear cover here. And we take the clear cover in case of the slabs 1.5 inches usually. 1.5 inches usually. While in case of the slabs we take 0.75. In case of beams we take 1.5. So this is the D. Removing these two from the D, from the width, the depth of the beam, we get the distance D. And D, in this case, let's take an example that the width, the total depth of the beam is, let's suppose 2 foot. So how we calculate the D? So D will be equal to the 2 foot minus this 1.5 and this 1.5. What we get? 3 inches. We get 3 inches. So 2 foot is equal to the 24 inches minus 3 inches. We get the 21 inches. So 21 inches is the D. So here we will put the 0.42 into 21. So what we get? We get here, after calculating 8.8, we almost take 8.8, yes, 8.8 inches. It means that the length of this crank bar is 8.8 inches. If this crank bar is placed at 45 degree, if this crank bar here, this crank bar here is placed at 45 degree, because this equation is applicable when the crank bars are placed at 45 degree. So we can use this equation to find the length of the crank bars. So this was all about the crank bars. Hope you understand, and it will really help you if you watch it clearly and understandable. And don't forget to subscribe our channel for coming civil engineering videos. Thank you for watching and share our video.